We are back with another episode of Scaling Robotics. Scaling Robotics is a series of conversations with leaders at robotics companies who have actually scaled their fleets. We hope to democratize these hard-earned lessons that these folks have earned to benefit the next generation of robotics companies and builders. Today, I'm here with Usman. Usman is a founding engineer at Aigen. Thanks so much for being here, Usman. Do you mind introducing yourself?
Hey, yeah, thanks, Vidant. My name is Usman. I'm super happy to be here. Thanks for having me on. I'm founding engineer at Aigen. We build autonomous robots for agriculture with the mission of regenerating Earth with robotics and AI. We can get into that a bit more, but that's me.
Thanks for being here. So let's talk a bit more about Aigen. What do you guys do tactically? What are your robots? And can you share a bit more about the scale of your deployments or customers, things like this?
Primarily, we see ourselves as an Earth-focused, climate-focused company, right? And so when we say that we're building robots for agriculture, it's not just agriculture. We're saying that we want to build a robotic platform for the outdoor space. And starting with agriculture, why? Because most of the land use in the world that humans use is agriculture. And so, if you want to make a difference to the planet, if you want to do something with this physical footprint of what we have on this earth, then you have to start with agriculture. And there's big problems in there that deal with um, carbon, that deal with the sustainability of the food we eat and food systems. And so ultimately, we're a mission-driven company and we wanted to solve a real problem with robotics, right? Rather than trying to make up a use case, for the technology. We thought about kind of what is the gap that we actually need to build to make a difference. And so that brings us to, what our robots are. They're a completely zero input, self-sustaining autonomous robot. So it runs purely off solar. And really you can imagine it as like a rover platform. You can imagine like your Mars rover. This is like an Earth rover, right? And so we have different payloads that we attach to it. And today's formulation of the robot exists to solve the biggest problem in agriculture, which is weeding, and also unlock different insights and data and things like that. That there's a lot of, I think, interesting opportunities with the way our platform is built. But really, we want to offer a scalable, low-cost version of a robot that's truly autonomous. You don't have to touch it. And I say the word truly autonomous here because I think that zero input piece is really important. It means you don't have to go and have a person plug it in. You don't have to have somebody go and do a fuel swap. And so a lot of our design decisions are very intentional about that. Even the way it weeds, we don't spray or require, loading up any type of, fuel. It's all mechanical action. So that's the robot platform, and yeah, it's built to scale, right? And so the idea is that we have fleets of these operating, hopefully all across the world.
On that point about a truly autonomous platform, uh, I think, like you said, a lot of people focus on the technology aspect and the autonomy aspect, and maybe not enough about the actual mechanics and operations. Like, am I going to have to plug this in? Give me a sense on like why that's important for customers and what you feel like maybe other robotics companies may be overlooking with this part of autonomy.
Yeah, I think autonomy really is the dream of robotics, right? Because the idea is that, aside from some narrow use cases, when we're talking about robots, for the most part, we're talking about things that can, these agents in the physical world that can go and carry out a task, right, without having to have human oversight. And we've been hearing for a long time, you know, I've been hearing this since I was a kid. Probably my parents' generation was hearing this too, that, in the future robots are going to do everything. Uh, we haven't gotten there yet, and it seems like we're always X amount of years away from that. And that's because there's a long tail of just a bunch of different challenges, and some of them are not very obvious or straightforward. One of the big blockers for autonomy is thinking about what are the humans in the loop in your operation, right? And when you think about scaling, that is really the bottleneck, is how many humans do you need for X amount of robots or X amount of area that you're servicing, or whatever it may be. And so making design decisions that are aimed at reducing the amount of human oversight, the amount of human effort that's required to keep your fleet running, is really, really critical, right? And so you could put all the technology that you want. You could make it have these really robust algorithms, right? That can stop your robot from getting stuck, that can, make sure that the robot can figure out any type of situation. Sure, it's a really smart robot, but at the end of the day, if you need a person to go and swap batteries out all the time and, need to change fuel, then ultimately it's never going to scale, especially in something like agriculture or, anything in the outdoor space, because, I've literally done this. I've been on the field and been like, okay, I'm on this farm for a few acres. The robot's a couple miles away. I have to like walk over to the robot now. And, I've been out there with our field team in the early days when we were, ironing out the kinks. Today, I'm happy to say that we can now remotely operate and troubleshoot a majority of issues without having to have a person on site. Um, and that is definitely a huge unlock, right? And having power all the time is massive, right?
That makes sense. I think also it seems like another bottleneck for, true autonomy is something that we've discussed, which is reliability, right? Both, I think, on the software and hardware side of the house. You recently had like a very interesting post. You quoted something that I had shared about that hardware is actually maybe a bigger bottleneck in reliability than folks, including me, might have thought. Yeah, I guess like I would love to hear a bit more about what are some of the biggest reliability challenges in hardware. Would love to hear about some of those things that you think about when you think about those challenges.
Yeah, I mean, I could talk about this for a long time, but I'm going to try to keep it concise here. Going back to kind of what I said about why we don't see robots everywhere, I think, there's a lot of reasons for that. But one hardware is maybe the biggest one, right? Maybe even more than software, which I harp on this point a lot because I used to hear this in school all the time. I'm a software person. I work on ML. I'm an AI background. I forgot to mention that in the intro, right? Um, and so when I was in research and all that, I used to hear from like academics and professors all the time that hardware is solved, in robotics, and we need to just solve the software. And that's just not true. It's just a straight up lie. It's not true. Because a lot of the problems have to do with different types of failure modes that can happen. You're dealing with the physical world, and so you have people who are applying a lot of, I guess, SaaS thinking, software, that type of thinking, to like a hardware problem. And so when you're building and you're iterating, it's like, okay, if there's a problem, you can't just, go and hit compile and now you have a new part. That's not how it works, right? You're gonna need to, if something breaks, okay, you have to think about the supply chain. You have to think about making sure inventory is right. That changes the whole way you manage capital. It affects everything. And I would say, especially in our early years, like the hardware challenges and supply chain and getting all of those things to be right, was one of the biggest one of the biggest challenges, like for sure, if not the biggest one, because it affects everything downstream in ways that you don't expect or anticipate, and in ways that you're not able to iterate on quickly. Software, yeah, there's a bug, you can iterate on that quickly. We can give you a fix tomorrow, it's fine, right? Hardware is not like that, and so the design cycles as well are also longer. And so I would say just the meta point here is that there's a compounding effect with anything that's hardware related, and that snowballs in a way that doesn't quite happen with software.
Yeah. Coming from the SaaS world, it is easy to just, yeah, like you said, just run the program again and use Cloud Code to tweak some things. You can't really do that when it comes to building hardware.
Um, so we had our robots in the field deployed, everything was looking good, uh, and so we leave them overnight, right? And and then because they run on solar all day, and then they sit at night, chill out a little bit, and then when the sun comes up, they wake up and they start working again, right? So in the morning, I try to SSH into, and try to see what's going on with the robots, check status and stuff like that. And I'm like, okay, I'm not seeing any of the robots. Like, what's going on? It turns out there was like a freak storm in the middle of the night that basically leaked water into the battery enclosures on one side. Even though they're waterproof, sealed, everything, right? We tested it, rigorously, but this was just the kind of those really strange storms that just doesn't usually happen. Water gets in and onto some of our PCBs inside the robot, and we had to go do a swap. I mean, because we designed our hardware to be very minimal, it wasn't hard. So we had to send our team out there, and they did a couple swaps, and we were fine. But that's the type of thing, like, you can't predict that, man. Real world. You have to just react somehow.
Yeah, the real world is good at just throwing these crazy edge cases at you. I guess in that world where there's everything that could possibly go wrong does go wrong. Anything is possible. You're not in a constrained software environment. How do you think about designing systems to be reliable under those conditions? You mentioned some things like keeping your hardware minimal, yeah, maybe to reduce the failure points. But any other like tangible things that you try to focus on when building your systems?
Yeah, I think, well, the first one is, like we say at Aigen a lot, simplicity over complexity, right? And I think this is one of the things that does also make us different from some of the other, robotics companies out there, is that we really try very, very hard to solve every problem in the simplest way possible with the fewest parts and just minimize the scope of things as much as we can. Uh, and so because it's like you get this compounding effect with each new thing you add. Let's say if you want to solve a problem, right? And you're like, okay, you know what, I could add this sensor, maybe a lidar or whatever it may be, and that'll solve my problem. The thing is, like, what are all the things that you haven't, all the assumptions you haven't accounted for in introducing the hardware change, right? Like, okay, now you've changed. First of all, you've changed your bill of materials. Okay, now you're changing your supply chain. Okay, now what happens if the sensor you're relying on fails? Okay, now you need to have a redundancy for that. Okay, now you're introducing all these extra layers, right? And so that ultimately is the reliability problem, right? That now you have to deal with all these different types of things. The other piece with reliability is, I would say, like, this is kind of more on the software side, is reducing bloat as much as possible. And this is like similar to hardware, but uh, it's very easy, in the software world to just, add more features, add more things. And then when you have bloat, especially you're running on with constrained resources, unpredictable things can happen, and you have to start debugging it at different levels. So I think those are a couple of things. And then finally, I would say just, everybody knows this, but you have to test a lot, like all the time, and just really emphasize that. And, resist the temptation and just be like, okay, I'm going to call it done, move forward. And, just make sure you're really hammering it out and breaking things.
It sounds like both for hardware and software, simplicity over complexity is the key for increasing reliability, just reducing the surface area for things that could break. Um, you said something interesting though about testing, and I do want to dive deeper into that. Um, yeah, I think like you said, it's easy to just build something and have the urge to just ship it. Robotics testing is definitely a lot more rigorous than the world of software. What does it look like to test at iGen? Any things that you think you guys do particularly well that are worth sharing as pieces of advice for other folks?
Our robots are, very down to earth robots, literally. Like we don't have, they're not super fancy, expensive, all these parts that go into them. Because of that, and because of their form factor, it's not this big giant machine that enables us to be nimble. If we need to test, we have, farms here locally and here in Washington. Yeah, throw a robot in the back of the truck, let's go. You know? And so that is something that is, I think, a huge, huge unlock, is being intentional about your design and giving yourself flexibility, right? And so if you design for flexibility from the beginning, then that also helps you test more easily, right? We don't need to, like, anyone in the office right now can go and take a robot out and test, and we frequently do, but people from different teams. And so I think one of the things that really helped us is reducing the barrier to entry to test. Because why do people not want to test? Like, as an engineer, you don't want to test because you're like, man, it's a lot of effort. I'd rather be building a feature, so you have to make it really just like stupid simple to test, and not a lot of work.
So we talked about reliability. Maybe we can move on, I guess, towards building. The word people are calling it these days is physical AI. Um, Whenever we're going from R&D in the lab to production, what are some of the assumptions that you're most keeping an eye on? This is probably going to break, whether it's like the model performance or system integration. What are the things that you're super cognizant of when you go from R&D to production?
I think yeah, there's a few. One is scale. That's, obvious. That's always different. But in our case in particular, uh, it's interesting because, you know, like for example, we build our little test environments, and generally I think most robotics companies will do this, where you'll have your test environment, you'll try your best to mimic kind of what your production environment's like, but there's just a different scale of things, right? Um, so like, one example of that is, let's say you're using a map to navigate your environment, right? Your test environments may be small, right? In our case, our production environment is like several acres, right? And so that's something that you have to be, conscious of, and that can cause things to break. But I think the problem is that the physical world is not very neat. It's not very, it doesn't fit into our nice assumptions. And so you have this super long tail of edge cases of things that are very just difficult to model. And so I keep an eye out on those types of things, and just understanding kind of what are the deltas between the environment you've been testing and building in versus the things in production. Especially, you have to challenge your assumptions there, because there's a lot of things that you might think that, okay, this is a good enough representation of what's in production, and surely this variable is not that big a deal. And it's like, spoiler alert, it is a big deal, right? Like, so I guess those are things that I try to keep an eye on. Anything that is hard to model will probably throw a wrench, one way
Yeah.
or another, even if it seems small.
What is there a specific example that you remember where some assumption that you made about like the system or about the production environment you felt wasn't a big deal, and then you actually saw what the farmer was doing, and you're like, wow, this is not what I expected or accounted for at all?
There's a couple. I mean, one thing that's interesting is how much lighting can change based on, you think, okay, you know what, I have data from, sun up to sundown, should be good. But even the landscape, like the topology of the landscape, can affect lighting. Uh, and so, you have interesting things like that happen. Another thing that was really interesting early on was, we tested our whole system, and things like that. Things are working. We're picking out the weeds and all that. One thing that I think we had to learn was how many different types of soil there are. Like how much it can change. Especially some of the soil in some parts of the United States, like in North Dakota, you get this really mud-like soil that when it rains heavy becomes completely impassable. Like humans can't walk in it either. Um, and then it hardens and becomes like clay, or like it's just like almost like a brick. Like you could build a house out of it. So it's just like those types of things are just like, wow. I mean, okay, we know that there's going to be some level of soil variation, but not coming from an agricultural background, it's hard to anticipate, like, okay, really, to that degree, like that type of soil. It's almost like you have to experience it and then like have your shoe get stuck in the mud to really understand it.
Yeah. And that's probably why it's so useful that you were out in the field, like you said, in the early days. Um, once the fleet scaled and now you have a lot of robots that are out there in the fleet and you're deploying new models into production, what does roughly the pipeline look like from training a model to deploying it, rolling it out across the fleet? Don't spill any secret sauce, of course, but really curious to just hear kind of what a production rollout looks like on that side of the house.
So we typically, prior to, like, let's say a customer deployment, let's say we're going to a crop, we collect data on that crop. We do initial, our model development and stuff like that. And so we go in on day one with, oh, a working model for, and I'm talking right now for like perception, right? Seeing all of the crops and the landscape and all that type of stuff. Um, but here's the thing: we don't expect, like, I never expect that it's just gonna work, because I know that every field that I go to, there's gonna be something new, something different about it. And that's just the nature of agriculture, is everybody's doing something different. Things are so different, region to region. You could drive 2 hours and it'll be like, wow, this field is completely different. Um, and so because of that, I think like part of the problem is like we shouldn't expect that our thing is just going to work out of the box. Rather, instead of trying to do whatever we can to make it work out of the box, I would rather invest in flexibility and adaptability. And so that's what we've done. And the way we've built our pipeline is to be able to do really quick turnarounds and fine tune our models. And so that's sort of the thing that we've emphasized. So what it looks like is robots go out there, and then on day one we collect data, and within a couple of days we spin out a version of the model that is now fine tuned for this field. And is capturing, and so we have a few different things in the pipeline. We use active learning and several other techniques to get the best data possible, and then make sure that's annotated with high quality, and then use that to roll things out. So basically, yeah, I guess what I'm saying is it's about adaptability and investing in that in the pipeline rather than trying to chase this dream of general robustness no matter what.
Sounds like maybe another a case of keeping things simple and modular so that you could, I guess, more easily implement these kinds of little things.
Yeah, one more thing I'll say about that is people underestimate the importance of having a really robust ETL, like a really robust pipeline of getting your data in. Uh, Especially because sometimes it's messy, right? Like, maybe the robot had it shut down unexpectedly, or something happened to the data, or for one reason or another something is missing, or something else is missing. So you really want to have, and it sounds basic or simple. It's not. You need to really think through. Like this is, I think, one of the so there's places in engineering where you're like, okay, let's start with something, let's iterate. And there's places in engineering where you're like, okay, let's sit down and think about what we want to do, and be like really intentional over here. I would say data pipeline is one of the second, where you sit down, you really think about this type of thing, because once you start doing it, if you make changes, it's painful. So you want to minimize that, and like you don't want to be in a situation where you've collected a whole bunch of data, then you're like, snap, there's this problem, and now this data is not usable, right? Or it's not as usable as it could have been.
And would you say the bar for good ETL is higher in robotics given that, there's data drops that happen all the time, like you said, maybe incomplete data, the fidelity of the data is quite high, like LiDAR, video data, and that makes it such that you need an even better, more well thought out pipeline like you were mentioning.
Yeah, I think that's definitely true, especially because the real world is also more unpredictable. You want to make sure your pipeline is really solid so that you're actually capturing those distributions and things that happen. And so like we record huge amounts of data, we eat the storage costs because it pays for itself, when we need it. Like if something happens, there's a motor failure or something, it's very difficult to understand what's going on. Like you need all the context, you need all the state, you need all the information to really be able to debug things. Um, and so I think, yeah, the bar is definitely higher in robotics just because of the unpredictability of it. The nature of the beast is that you have all these different uh, components and layers of complexity.
Sounds like one of the, I guess, maybe hot takes you have is that you should be storing all the data because the ROI there is super high, where maybe some people wouldn't agree with that. They want to cut down on those costs. When you look around the industry, are there any other, hot takes that you have or strong takes that you have about data requirements and data needs?
All right, so here it is, guys. Lower your frame rates. I feel like yeah, everybody wants higher frame rate. More information is better. You have all this information. Uh, and I think there's a caveat. There's a time and place for that. Sometimes higher frame rate is good, but a lot of the time, the frame rate that we're using, right, or just in general, abstract the frequency of the information that you're getting is not actually what you need. You just arbitrarily decided maybe you want 30 FPS. Do you need 30 FPS? Maybe you could compute things a lot more efficiently and drastically reduce kind of the whole compute profile of your system, um, with a lower frame rate. And so I would say this feeds into maybe the general bigger hot take, which is that I think a lot of people in robotics want to say, okay, guys, robotics is kind of bleeding edge. So what we're going to do is we're going to give you We're going to solve the problem with no matter what it takes, all the resources, right? We're not going to constrain everything. We're going to solve the problem first, then we're going to optimize. I think this is not the way to do it, because what's going to happen is you're going to solve the problem. And once you solve the problem that way, it is very hard to say, you know what, we're going to throw that away, we're going to optimize it. It's not going to happen. Like 99% of the time, it's not going to happen. Versus you constrain yourself, you really squeeze yourself, try really hard. Okay, you're going to get stuck. Okay, fine. Now we'll add the thing. Um, and there's a balance to be had over there, right? But thinking about the end goal from the beginning is really important, because once things balloon up, is very, very difficult to recover. And if you get stuck like that in a startup, especially, that's like death, right? Like you've developed yourself into a hole.
That I think that is a hot take. I talked to Amit Moran. He's the CTO of Civ Robotics, and he said something similar, which is you have to have your target bomb in mind from day one. A lot of companies will mistakenly think, oh yeah, once we get to scale, we can just cut this stuff down because we'll have figured out how to do it. And in fact, it actually gets harder to cut things out as you scale more and more. And it sounds like you guys also took the same approach of let's set tight constraints at first, so that we can make sure this is a viable, economically viable product to sell and scale.
About the thing about collecting all the data, like that was also hotly debated in amongst our own team. We're like, all right, is it worth it? Because it does introduce overhead, you know. I think it's definitely worth it when you're developing, because you learn things and it's all about these unknown unknowns, right? And so the faster you can take care of those unknown unknowns, the better shape you'll be in. Uh, I would say another one of my hot takes, I guess, that would maybe is becoming more popular now, is just doing perception just with vision. Um, and this is an approach that we chose to take, that a lot of people, I guess, this is a hot thing, highly debated in the community, is like, all right, should you have LiDAR, what modalities you have, go the sensor way, put all the sensors on it, versus just use a cameraman and, you know, try to be smart about everything they implement. I think I lean to that side just because of, less hardware, you know, which, to be honest, I don't think that there are maybe some companies that take this approach, but most robotics companies, I feel, kind of make hardware an afterthought, and it's like the software is like, okay, we can do whatever we want. Here's all the algorithms. Here, you get a lidar, you get a depth sensor, you get this, you get that. Like, we give all the software guys everything they want, and then the software guys are really happy. Or like, here, you can have all the compute, um, and compute everything. So I think this is very different from how we do things, right? We're very much about minimizing that. And then even on the compute side, right, is being very minimal about it.
We spoke a lot about data. Something that I'm seeing, especially as a startup founder in SF, is all these companies popping up trying to be the scale AI for robotics data, right? Whether it's egocentric data or remote teleop, these things. Um, how do you feel about that kind of data collection? It sounds like at Aigen you guys are just collecting data that your robots actually encounter in production. But yeah, I'm curious to hear your take.
I think there's a lot of interesting opportunities over there, because this actually leads me to something else. I was actually gonna I was thinking I'd make a LinkedIn post about this, called why why physical AI will not have a ChatGPT moment in 2026. And the reason is it's a data problem, right? This is maybe a bit of a tangent, but the thing is, what happened with that we saw with large language models and even diffusion models, kind of these big transformer architectures that you have out here, is they were not enabled by we had some revolutionary idea that kind of was like a breakthrough. That's not what happened, right? It wasn't even like, okay, someone, like when gradient descent was invented, that was pretty crazy. Like, dang, gradient descent. It wasn't like that. um what it was we figured out how to scale huge amounts of data into very large models. That's what it was. In robotics, we don't have that data. It doesn't exist. You don't have general data that you can train one model that it will all understand in some unified representation that all makes sense. So I think it is a problem. I'm not super familiar with what exactly these companies are doing in terms of trying to create this type of data for all robots. I suspect the wrong approach is to try to say that, okay, we are going to collect data for this specific type of robot and expect that the industry is going to use that type of robot. Whether it's, let's say, a particular type of architecture with a robotic arm or, whatever it may be. And I think the reason for that is because there's a lot more design space in hardware than I think a lot of people, a lot of people take that for granted. And, that just changes the data requirements dramatically. But I think there is interesting work in figuring out how you can take this sort of general data piece and then bridge this gap, right? And having a model that can understand the physics of the real world, and in order to create that. And this is also something that I can't discuss too much, right? But it is something that we are interested in, as one we've been thinking about because we have pretty much the perfect platform for collecting data outdoors, maybe even indoors, because you have a system that's always on, always connected, powers itself. And not only that, but it's modular. So we've designed it to be modular in terms of the different payloads you can attach to our rover. So you could attach cameras at arbitrary angles to whatever type of sensor that you want. Um, and all you got to do is, connect it to our rover, right? And it'll drive it around infinitely, right? And just collect whatever data that you want. And we've also solved problems with outdoor autonomy and navigation and stuff like that that allows for this type of collection at scale. Uh, and then on top of that, because of the modular system, like we haven't done this, but you could imagine even putting any type of, I don't know, robot arm or end effector that you want on there, and then going and collecting this data.
Because the ChatGPT moment is not coming in this year. What does that say about how companies will use these VLAs like Groot from NVIDIA or Pi in production systems, if at all, this year?
I think it's not going to be anything super new or different. They'll people I think will be using them as they've been doing, right? Which is, essentially like the idea is that you're moving towards this end to end sort of philosophy. I think that is a process that's happening, right? So traditionally, kind of what we've been doing in robotics is, uh, you have your perception stack, you have your planning stack, you have your control stack, and these stacks kind of talk to each other. But they are kind of each their own development teams, and sometimes companies will actually have, separate teams for each of those. Now, what's happening with vision language action models and things other than that is let's make one model that will take vision as its input, give you action as its output. I think it's a really compelling idea, and it's a cool dream. It does need a data flywheel to make it work well. That's one piece of it. I think the other piece of it that I think maybe will be, I suspect, a big topic of development this year is knowledge distillation. Because the problem that people are running into and will continue to run into, and this is, I guess, this depends on, what type of robot you're talking about, right? But all robots need power, right? All robots need power. We're solar powered, not everybody is, but battery swaps suck. And so you're gonna have to charge yourself somehow or do a battery swap or whatever it may be, unless you're like, in a factory hooked up to power or whatever it may, something like that. And because you're power limited, that naturally makes you compute limited because you can't just arbitrarily throw whatever number of GPUs you want on the robot, right? And because let's say you did that, you reduce the battery life, you're just like, whatever, screw it, we're just going to put all the compute on the robot. Then we get into that problem that we talked about before, which is now you're actually requiring more human oversight, and you have this fancy smart robot, but it needs like humans to babysit it all the time. So it's like, what was the point, right? So because of that, there's a natural constraint that's happening. Whenever power is constrained, compute's constrained. Whenever compute's constrained, now it's like, okay, how do I take my big fancy VLM and make that run the way I want, right? If I run it in the cloud, I'm going to have latency issues, connectivity issues, right? Depending on the use case. Um, and so knowledge distillation, I think, is going to be really key and really important, which is now we have these big, great foundation models. How can I distill the knowledge from this big, great foundation model into a model that fits on the edge? And there's a growing body of work around this. Um, and there's a variety of different ways. It's knowledge distillation is, well known, especially in other fields, but I think it's relatively new in terms of how we do robotics and actually making its way to deployment. So I think that is what's going to be a major focus and sort of, I would say, the bridge between the current era of robotics and sort of the next.
Uh, yeah, I think this has been a great conversation, Usman. Thank you again for taking the time. Um, in closing, what advice would you give to founders or engineers who are about to scale their first real fleet of robots?
Yeah, I would say one is invest in flexibility and adaptability because rather than trying to predict everything that's going to happen, uh, because realistically you're not going to predict it. And so if you invest in infrastructure that lets you adapt, you're going to be in a much better spot. Uh, Two would be, and I always say this: try to keep things as simple as you can. Try to reduce scope, and especially for the first time, because there's going to be a lot of unanticipated things that go wrong.
Yeah, last thing, any way the audience can help you? Any shout outs or calls to action? Are you guys hiring?
My one ask is to go and build something that has a real mission behind it, right? If you are, um, a founder in robotics and you're trying to get into this space, it's gonna suck. Maybe this actually goes back to one of the last pieces of advice that I would give is pick a really good problem, pick something that's gonna like keep you motivated, keep your team motivated, and keep you guys pushing to push through. Because when things get tough, there's gonna be a lot of stress. There's gonna be a lot of things going on, and you need something to kind of help you make it through those times. And so mm, investing in that, like being in that type of problem space, and not only being in that space, but also having that culture in your team and that understanding that this is what we're here to do. Uh, I think that's super important, and it'll only add to your success. But the reason that's also one of my asks is because that's kind of what I would like to see more of in the world, and that's kind of the type of company that we are. Maybe it's a cliche, mission driven company, but I would say we really mean it. Like at least I really mean it, man. Like I'm not blowing smoke here. Like this is like uh something that's actually important, and I think this is what's gonna make robotics actually make its way into the world, right? If we're just building it for the sake of building a technology, then ultimately we're not gonna solve these problems. So really, I guess focus on the problem. Don't get dazzled by the hype of having a cool robot moving. I know robots are cool. We all think robots are cool, but focus on the problem rather than on the hype. Um, is both my advice and my ask for the field. In terms of Aigen particularly, I would say engage with us is good. Follow us on LinkedIn, connect on LinkedIn, whatever it may be. Uh, because ultimately, I think what we want to do is also be a voice of a different way of doing robotics, one that's lower cost profile, lower physical profile, right? Less resource intensive. Um, that I think is sort of almost a movement that needs to happen because there's too many, I guess, there's too much of this. I want to almost say it's almost a hegemony of this approach of a lot of dollars, a lot of cost, big, power hungry, all this type of stuff. But for that reason, I would appreciate it if people would engage with us and join us in this type of way of doing robotics.
Awesome. Usman, thanks again for your time. This was fantastic, and we'll see you later.
Yeah, thanks, man.